Do you remember the very first shape you learned when you were little? It's okay if you don't. But do you remember when you used to draw your house using nothing but triangles, squares, and rectangles? These shapes all have a name in common, and that is the polygon. The word polygon comes from ancient Greek. Poly means many, and gon means angles. So generally, polygon means a shape with many angles. In math, a polygon is defined as a closed two-dimensional shape formed by 3 or more straight line segments. By definition, all of a polygon's sides must be straight. If any side is curved, then it's no longer a polygon. Also, a polygon must be closed. If you draw a shape and your endpoint is not the same as your starting point, then you don't have a polygon. Let's now do a quick check. Is this shape a polygon? It is a closed shape and formed by straight line segments, but hang on, it is not a two-dimensional shape. So this is not a polygon. Some common polygons include triangles which have 3 sides, quadrilaterals, 4 sides, pentagons, 5 sides, hexagons, 6 sides, heptagons, 7 sides, octagons, 8 sides, nonagons, 9 sides, and decagons, 10 sides. Polygons can be regular or irregular, simple or complex, concave or convex. Regular polygons are polygons that have all sides and angles congruent, whereas the polygons that do not have all sides congruent and all angles congruent are irregular. Simple polygons are polygons without self-intersecting sides. Complex polygons, also called self-intersecting polygons, have sides that cross over each other. Let's extend the exterior sides of a polygon. If they intersect at the interior, the polygon is concave. Otherwise, the polygon is convex. When working with polygons, you may need to find exterior angles as well as interior angles. Remember that the following rules only work for simple polygons, including convex and concave ones. However, the examples of convex polygons are much easier to understand. An exterior angle is an angle between any side of a shape and a line extended from the adjacent side. If you count one exterior angle at each vertex, the sum of the exterior angles of a polygon is always 360 degrees. An interior angle is an angle inside a shape. The interior angles of any polygon always add up to a constant value, which depend only on the number of sides. In a 3-sided polygon or a triangle, the interior angles add up to 180 degrees. For a quadrilateral which has 4 sides, the constant value is 360 degrees because a quadrilateral can be made from 2 triangles. A pentagon has 5 sides and contains 3 triangles, so the sum of its interior angles is 540 degrees. It is easy to see that there are always 2 less triangles than the number of sides, so the number of triangles in a polygon can be found by subtracting 2 from its number of sides. Then, multiplying this difference by 180 degrees, you can find the sum of interior angles of the polygon. Now, let's try finding the sum of the interior angles of a decagon which has 10 sides. The result is 1,440 degrees. If a polygon is regular, which means all of its interior angles are congruent, Then you can easily find the measure of each angle by dividing the sum by the number of angles.